Hello everyone, let's cut to the chase here. This is a walkthrough of the IST769 Lab C problem set. If you're having trouble with the problem set, you can watch me do it. It's a great way to sort of follow along. I do not recommend doing this to start. I only recommend doing this if you get stuck or can't figure something out or have trouble figuring out how I did it. So this lab here is about Hadoop and mainly HDFS and using Hive. So there's a couple tools we're going to need to start with this lab. We're going to need access to a Linux client that will have the Hadoop tools on it, so that I can do this from my Windows terminal here. So I'm out at the command line here in Windows at PowerShell. And I want to complete this command here to connect to my Hive server. So start there. All right, and now I'm in the Hive server. And I'm actually going to do this maybe with another tab. So that way I can have a Hadoop client and then stay in the Beeline client. You don't have to do it that way, but since I'm on video, I might as well show you some tips and tricks. So I'm going to zoom this in, get that going. Let's see, how's that? Maybe one more. Okay. I need to get to the right folder for me, where my advanced databases stuff is. And now I can do a docker compose exec Hive server bash. Whoop, got to spell compose right. There we go. So now I'm in here. This is me. I'm out here. I can do Hadoop fs and do those commands. And then I am going to connect this guy to Beeline. So if I go back to the lab, here's the way to connect to Beeline, the Hive client. That way I can leave my Hive client up and running. I don't have to screw around with that. So I'm going to paste that in there like so. And now I have, maybe zoom it in a little more. I can't do clear here. That's not how it works in Beeline. I have a setup where this one is using Hadoop and this one is in the Beeline client, show databases. And this one is just the regular Linux terminal. Okay. And then what else do I need for this lab? I also need access to the web HDFS client, which I will pop up in my Brave browser. Hive 0070. Okay, so that's going. And then I also need access to Jupyter Lab, and I have that going right here. So this is everything I need. So that's just prep. I know it's a long bit of prep, but we're good. So let's go on and do the first question in the problem set. So first question in the problem set says we need to connect to a Hadoop client and take some files that are in the datasets folder and get them up into Hadoop. So we want to take them from the local files over here, and then we want to copy them up into Hadoop. All right? So first things first, I need to know where these files are. So there's a couple ways you can do this. If you're just out here at the Linux prompt, you can do like an ls datasets, and then you'll see a bunch of folders in here. And then if I go back and look at that lab, it says customers, customer CSV, right? Customers. I see a customers right here. Customers. And gotta spell it right. And then there's a customer CSV. So I want to put that into Hadoop. So the command to do that would be Hadoop, Hadoop fs put and then I want to put data sets, customers, CSV, and I want to drop that in user root lab C customers, I think is where I want to drop that. And let me go take a look at the docs one more time. Yeah, user root lab C customers. Now I could put the file name, but I shouldn't need that because of the way Hadoop works. Okay, it says no such file or directory. I might have to make this folder first. So let's do Hadoop fs make directory user root lab C. Okay, then let's make the customers folder. Whoops, son of a gun. There we go. What? Oh my goodness. Lab C customers. There we go. And then now I can copy. All right, now I'm getting a file exists. Oh, you know why? Because I'm just like blindly hitting up arrow without using my put command. Okay, so now it got put. So now I can check it. Hadoop fsls to look at it, and then it's user root lab C customers. And let's see what's in there. And you'll see in there, there is a customer CSV. And there's also a Hadoop because I was a knucklehead. So I'm going to actually remove this folder. Hadoop fs rm. I want to force that remove. And then let's use user root lab C customers Hadoop. Get rid of that. Got a rmdir, I bet. rmdir. Okay, now I should be exactly the way I want. The first one, if I can get an ls, there we go. Just that. Let's go verify that on web HDFS, right? This is just the same thing, just using it through a browser. So I need to go, whoops, not logs. I need to go to utilities, browse file system. And let's go user, root, and then see, I made a whole bunch of folders because I just completely hitting up arrow like a knucklehead. Lab C, and then customers. And there it is. I'm not going to worry about the other folders. I'll just delete them later. All right. So I got customers in there. Let me go do the other ones now. So let me go back and read. I got to do surveys from customer surveys. So if I actually hit the up arrow correctly, I could probably find the put. And then this one should be customer. This should be surveys. And then that should go to surveys. And this should not work because there's no folder called surveys. No such file or directory. So I first have to do an mkdir, right? So I have to do a Hadoop fs mkdir surveys. And then I can do a put. All right, and then let's go take a look at it. Let's go over to web HDFS and take a look at it. So here's the customers folder. I got to reload the page. Now there's a surveys folder. See, it says D. That's how you know it's a folder. D for directory. And then I go into surveys, and then poof, there's my file. And I know this is a file because it does not have a D there. Good to go. Now, you might be wondering, all these commands you've been typing, how do you know what they are? And this is where you type in history, and you can see the last couple of commands. So when you're getting ready to hand in your assignment, you need to give me the Hadoop commands you typed so you can locate them here, right? So you can say, well, I had to make lab C, then I had to make the customers folder, then I was able to put that. Then I was able to make the surveys folder, and then I was able to put that information there. Okay, you just have to know which ones are the right ones, and this is something that you just kind of have to figure out as you go. I mean, that's the way it works. And then these are the knucklehead commands I made that made extra folders that I didn't want right here. All right, let's see what the last step is in question number 1. So question number 1 here, we have to put the tweets up, and we need to put them in this target location here. Okay. So now I know I'm wise. First thing I need to do is make the folder. So Hadoop fs mkdir user root labc tweets. First make the folder because I've learned the hard way, and now I can do a put to move the file, to copy the file, put, and then it's data sets tweets PSV. I think it's tweets PSV. It says in the doc what it is. Tweets, yeah. But you can always double check yourself by looking, right? Or trying it, and it'll say it didn't work, right? But this did work. But if, for example, I try tweet PSV, right, I'll get an error. No such file or directory. That tells you that this source is not available. You're looking in the wrong spot. You don't have the right thing. All right, let's go just verify this on web HDFS one last time. So I go back to lab C. I'm going to take out the surveys folder here. And I have a tweets, and then in tweets, I have tweets PSV. So I am all set up. I think that completes the first question here. Now, yeah, I got to record the commands I type, but again, that's where you use history. Use that history command to see what it is that you did, right? And then in there, I can find, well, I had to make the directory, and then I put the file up there. Right? So there should be basically 6 Hadoop commands that you use. And again, this is moving that file, or copying that file, I should say, locally up to Hadoop. And this is not usually how things end up in Hadoop, but this is the way things end up in Hadoop in this class because we don't have a production Hadoop system. We have a playground. All right, now let's move on to question 2. Create a Hive database called LabC. In the LabC database, create an external Hive table for the tweets. Okay, your external table will point to an existing location on HDFS. Okay, note, you will need to view the tweets PSV file in order to see the format of the file before you can create the schema correctly. Okay, there's a lot to unpack here. First of all, you got to know what an external Hive table is, right? Let's start by creating the Hive database. So I'm going to go back to my terminal, and I'm going to use this other tab up here because this one is in Beeline. And I'm going to say create database LabC. And that's going to work. And if I do use LabC, now I'm in the LabC database. And I can say show tables, and then I get nothing. Right? There's no tables in the LabC database. When you create a database, what is it doing? The metastore is just tracking where in HDFS these things are going to live. Remember, there's 2 kinds of tables here. There's the internal table and the external table. And when we make an external table, we are creating a schema that points to a location on HDFS. So where are these tweets? You got to know that. So I'm going to go back to this tab, my Hadoop command, and I'm going to go look at the tweets. So I'm going to type Hadoop fs, and then I'm going to use the cat command to look inside a file. And what I'm going to do is I'm going to cat out user root, not toot, root labc tweets. And that's probably good enough. That'll look inside the folder for what I need. Let's see what we get. Okay, I need a whole file. So let's do star. Okay. And this is what tweets PSV looks like. It has, it's delimited by these, which these are called pipes. That's what PSV stands for, is pipe separated values. You can always Google that if you want. Well, pipe PSV file. And then you'll probably get, pipe separated values. You can read about it all here. Either one of these will get you what you want. So knowing that, you can now try to make sense of the schema. Now, if I don't know what to do for these schemas, I can always just use the string type, because the string type is the most accommodating type and will just handle any situation we get ourselves into. So I might want to try for something different, but then if that doesn't work, if that doesn't load my schema right, I can always try it as string type. So I'm going to try it first with the most aggressive data types I can, and then if that doesn't work, I'll just default back to a string type and just throw my hands up in the air. Okay, so I know my location. It's right here, user root lab C tweets. Okay, I don't need the star. The star was just because of the way the cat works. So there's my location. So now I need to go back to Hive and we need to create our external table. Before we do that, we need to think about our data types here. So maybe what I'm going to do is I'm going to open up a place where I can type some notes in. Let's throw this over here and let's put this over there. We'll slide this a little bit over there like that. And then let's make this font big so that you can see that. The home audience can see it. That's good. And what I'm going to do is I know it's my location is this. And my delimiter is going to be a pipe like that. And if I try to think of my schema, the first value here, it looks like an integer. So I might want to try a big int. And then this looks like it's a decimal. So maybe I'll try decimal. And then this looks like it could be a timestamp or a date time. I'd have to look at my Hive types for that, but I think there's a timestamp. But in order to make it go in, I'm just going to use string because I don't want to mess around with timestamps right this moment. I just want to get it to work. And then this one looks like it could just be string. This looks like the username. And then this looks like the actual tweet, and that's going to be string. And if I'm going to give these names, I don't know what this is, but I think this is probably like the tweet ID is my guess. So I'm just going to call this one tweet ID. And then this decimal, I don't know what this is. I don't know, maybe it's the timestamp or something. I don't know. I'll just call it timestamp. And this one is the time of the tweet. But you can't call it time because time's like a reserved word and date's a reserved word. So I'm going to call this, and maybe timestamp is. So what I'm going to do is maybe put tweet in front of these. So it's going to be tweet, timestamp, tweet, ID, tweet, date. If you don't know what this is, if you didn't know what this was a timestamp, you could just call it tweet, decimal. You got to give it a name, right? You don't know what it is. Now, I can probably guess that's the user. So I'm going to call this tweet user. And then this is going to be the tweet text. So I've done them all. Now I have what I need to probably try to make the table, right? I'm prepared to make the table. So now I can go back to Hive and I can say create external. Now I might have to look at the PowerPoint to figure this out. I've done enough Hive where I'm just going to wing it. Create external table, tweets. And we have the tweet ID, and that's going to be a big int. Then the tweet decimal. You don't know if any of this is going to work until you try to close off the statement. Tweet, date, string. Oh, I forgot a comma. That's all right. I'll throw the comma there. Tweet, user, string, tweet, text, string. string. And now I got to do my usual jazz where I say row format delimited, fields terminated by a pipe. I can't remember if it's a single quote or a double quote. I think it's a single quote. Location is going to be user root lab C. Now, if you put in a location that's not right, you're just not going to see anything. Like if let's suppose I fat finger this, tweets, because, you know, it's been a long night. Right, and I show tables. And if I want to know the schema of the table, I can say describe tweets. You can see that. And if I want to see even more information about how this is set up, I can say describe extended tweets. And that will give me not only the data types, but it will also give me a gory set of information about, you know, how this table is put together, including the location right there. Okay, so now if I select, I should be able to select and see data because it's pointing at the data at HDFS. But in this case, I won't see any data because I'm not pointing at a valid location, right? I'm just not. So I need to drop this table and recreate it in essence. So drop, I wonder if there's a history here. I think it's like, help. And then I think there's a bang history. There it is, bang history, to display your command history. So I'm going to move this over a little more. So I could do something like this. I could say bang history, and then I get all the things that I've been typing here, right? So I can see where I typed in that external table. I can see where I showed tables and described tweets. So let's drop table tweets. Let's go back through our history and recreate our tweets. Create external table tweets. We had the tweet ID first. We had the decimal. I don't know what it is, but I need to put a column to it. And then the time. My comma there this time. I'm smart. And then let's do the tweet user. I could retype this, but you've seen me type. It's not pretty. And then let's do the tweet text. That closes out my columns, and then I need my configuration. Row format delimited. Fields terminated by location. And now I want to get the right location. There, that looks right. And then now I can do select tweets, and then boom shakalaka, I actually get data. Now it did truncate, if you look, it did truncate my decimal, and that's because I didn't specify a precision with my decimal. I didn't say decimal, 18.9 or something like that. I didn't do that. And it just truncated my decimal. So, I got to live with that. But for the most part, it came in and the mission is accomplished from my standpoint. So if I want to see all of the tweets from JPool, let's see if that works. Select, tweet text from tweets. where tweet user jpool. I mean, I know this is not what the question's asking, but, you know, I'm sorry, you're getting a teaching moment. So these are all the tweets from jpool. Okay, let's go see if we answered the question. After you create the table, write a select query of all the tweets for a single user. Okay, so I did do that. Okay, so they call me Nostra Mike. I predicted the future. Please include the HQL code you wrote to create and query the tweets table along with a screenshot of a described tweets command output with your select query output. Okay, so I mostly did all of that. So I think I've wrapped up number 2. Let me move on to number 3. Now we want to create an internal Hive table for customers. Okay, now the difference between an external table and an internal table is when you create an internal table, you don't need to specify a location. You don't need to put the location option on the internal table because it's going to pick the location for you. This is by definition of what an internal table is. And then we need to move the data in there, we need to use the load command. All right. So let's do this first. Let's create the internal table for customers. Again, before I can do this, I need to get an idea of what the customer schema looks like. So back to the command line over here, and let's get an ls of lab C customers and take a look at that. And you'll see that customers has a header row. So I'm also going to have to figure out how I can skip this header row. All right. So again, I'm going to use a little notepad to help me figure this out. So this is going to be an internal table. And I'm going to need a C. I'm just going to call it, instead of customers, I'm going to call it C first. And that's going to be a string. And then C last, and that's going to be a string. And C email, and that's going to be a string. And C gender, and that's going to be a, where is it? Right there, it's a string. C IP, and that's going to be a string. And then city, state, those are strings. C city, string. C state, string. Then I have this 1, this 45, and this 1. That's C total orders, total purchase, months customer. So C total orders, that's going to be an int. C total purchase, int. And C months customer, int. All right. And what is the delimiter here? It is a comma. Okay. But I don't know. I'm unsure if I'm going to need that because the internal table just stores it any way it wants, right? I'm going to load the data, and when I use the load command, I'm going to have to specify how that data, what is the format of the data I'm trying to load in there. All right, let's jump back to Hive. It's time to make our table. Create internal table customers. Now, after I make this table, I probably should go take a look and see where it's located within user Hive warehouse to sort of make sure that things are kind of where they should be and working the way they should. All right. This is going to be a long one, so I'm going to probably do a couple of these in a row. I'm just going to say C first, string, C last, string, C email, string, C gender, string. Maybe I'll move that down to the next line. C gender, string, CIP string, and what else did I have here? The order of these matters, right? Because this is the order that they are in the file here, right? So this order matters. So it was state, city, state, city, state. Yeah, just checking. C city string, C state string, C total orders. I'm going to regret having a long name, but that's all right. Int. C total purchased. Int. And C months customer. Int. And then I need to do my usual jazz. Row format delimited. Fields terminated by, and then in this case it's going to be a comma. Let me just go double check that. Okay, back here, comma delimited, right there. Okay, now that is the way I want. I don't need to give it a location. It's an internal table. Okay, and I screwed something else. I screwed something up. Oh, I don't need to say the word internal. I just need to say table. So, bummer. Let me do this all over again. Create table customers. Good thing I put multiples on a line, or else it would be here forever. Okay, show tables. Describe. Let me find it. Describe. Describe extended customers. I should probably just typed it in there. Okay, and now you'll see the location is user hive warehouse lab CDB customers. That location is internal. That location is internal. And if I go and do a select from customers, there's no data in there. Now, what I don't do is I don't go here and do HDFS put and then put it into that folder. That is not, and when I say that folder, I mean I do not just put it myself in user hive warehouse lab C customers. I don't just drop files in this folder. That is not how an internal table works. What I should be doing is using the load command. So the load command that we learned in class, I don't know how much of this is recalled to you, but this is why you got to take notes, maybe review the slides and things like that. There's a load command. I'll do it in caps. Load data in path. And this is going to load from HDFS to HDFS. If I say load local data in path, or load, I think it's either load data local. I think it's like that. In path, it's going to load data that's not into HDFS into HDFS. So I can choose what I want to do here. I think what I'll do is I'll try the local one. Let's say load local data in path, and then this is going to be not a Hadoop path, but this is going to be data sets, customers, CSV. And then I need to specify the table. So I want to overwrite. I could also append, but I don't want to do that in this case. Overwrite into, I think it's table, and then customers. I think I have to say table. Okay. It says no rows affected, but it should have worked. So let's see, select star from customers, do that. Now I see data, amen. Secondly, if I go back to the website where I have web HDFS and reload here, now you'll see there is a customers CSV file. See that? It's a file, not a folder, and it's right there. Okay, so good. I think I did it. Now let's go see if I answered the question. So blah, 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 blah. If you screw up, there is a header row in this file. Okay, so I may have screwed something up because I didn't deal with that header row. Let's take a look and see what the first couple of rows look like in the query. Limit 2. Now, see, the first row has city, state, gender, IP address. See all that? It's got all that in there. Yikes. I don't want that in there. So I need to skip that. And so this is where you need to set what's called a table property. So there's a couple of these, and the easiest way to find this is if you go to the Hive docs, and I'm just going to type it in here, Hive documentation, table properties. But it's somewhere in the bowels of the bowels of the documentation that I gave you for this unit. And see, like it says alter table and then set table properties, right? There's a table property to skip a header row. So let's go find that. Skip header row. All right, let's see what we get here. Oh, there it is. I just saw it. I don't know why I'm clicking on this one. This one is skip header line count 1. Right there. And then see it's down there. So I should be able, I think I can alter the table and add this. I can add this. These are like key value pairs that are like additional properties on a table. I think I can just add this. I'm going to try to just alter the table because I'm lazy and add it and fix this problem that way. So alter table customers, set table properties, that. Table not found, lab C, oh, it's customers, not customer, Mike. Customers. Okay, I did it. Now, let's do that. Select limit 2 again. See, now the first row gets skipped. See that? The first row gets skipped. Nice. That's excellent. I don't have to recreate the table. I can just kind of alter it. Same thing if I screw up one of these columns. Like with the tweets column, right? I had a decimal, but I want a different decimal. I can change that with the alter table command. I can do something along the lines of alter table tweets, alter column, what was it, tweets, decimal, and then let's set it to decimal, I don't know, 18.8. I think that works. Okay, so it could be set column. I don't have 100% the correct syntax, but I know you can do it. Let me just try set column for grins, and I know I'm getting off topic here. You're like, move on to the next one. Oh, okay. I won't worry about it right now. Anyway, that's pretty much, if I do the history now, I can, it's like this, history. I can see now that I have, there's my alter table, there's my load command, which I did in capital so it'd be easy to read. There's my create table. So I pretty much have everything that I need here in question 3. I've completed that one. Okay. All right, now this says, similar to the previous step, let's do surveys as an internal table. So this should be pretty easy because we already did customers. So doing surveys is going to follow the same kind of pattern. Again, first of all, you got to get an idea of what the hell the schema is and what you have to deal with. So let's do surveys now. Let's go over here. Let's go, I guess I can go here and let's do surveys. And it is comma delimited. Comma delimited. Oh, it's got a header. So it's got a header. So let me just take some good notes here. I'm going to need this. Table properties. I'll show you how to add that to the create table statement. I'm going to need this. Okay. I'm also going to need the delimiter of comma delimited. And let's see what I have for let's see what I have for columns. I have S email string for survey email, S Twitter string, S username string, S marital TAL status string, marital status. Household income looks like it's an int. Own home string. Household income. S income string or int. What's nice is if there's things in here like that say prefer not to answer. If there's like a prefer not to answer for household income, see that? It just makes it null. That's what's awesome about Hadoop is if you pick a type and the data doesn't fit that type, rather than throwing an error, it just nullifies the value, and that's good if you're trying to do analytics. So I have income. Where was I? Income, own a home. That's yes or no. Then I have education, and that looks like a string, and then favorite department. So the rest are strings. So I have S, home, own home, string, S, education, string, TION, and then S, favorite department, string. All right, and that should be everything I need to make that internal table. I shouldn't need anything else. All right, back we go. So create table. I'm going to use caps so you don't get thrown off here. Create table surveys. And then we got S email string, S Twitter, string, S user name string, S, that's too long, M status, string, S income, int, S own home, string. I could probably give these better column names, but I'm really lazy. S education string. You could do something like this, you know, favorite department, like that. You can make it, you can do a descriptive column if you want. I usually just avoid that. Just gives me headaches. Okay. Row format, delimited. Fields terminated by a comma. And then last but not least, my table properties. which I will paste in. Okay. Describe extended surveys. All right, let's check for things. There's my table properties. There's my location. Once again, let's load the data. And I'm going to use history to load the data. I'm going to find that load data. There it is. And I'm going to load surveys. And I'm going to overwrite into table surveys. Boom shakalaka. And then select star from surveys, limit 2. Let's just get 2 of them. There they are. I got a couple nulls in here. Did I screw something up here? Married, survey, income, email, Twitter, username, marital status. Oh, marital status says married. Income says that. Own home says null. Education says 4-year degree. Favorite department, electronics. Okay, I screwed something up here, which it's going to happen, but you got to figure it out. So let me give you the full screen here, and let's zoom out a little bit. Right? Let me zoom out a little more. Okay, and you see that favorite department is not education, says electronics. So something did not go right here. I'm either missing a column or I got my columns out of order or something. So let's take a look at the contents of the file. And what I'm going to do this time is I'm going to go back here and let's just take a look at it again. And let's go to the very top, right? So this first person is ojugladianriot.com. ojugladianriot.com. And then ojuglad married 65,000, no 4-year degree. ojuglad married. Okay, see, I missed username here. Twitter. Oh, because it's Twitter username. There isn't a username column. It's just Twitter username. Ah, so I added an extra column in here. So I have to actually drop my table and recreate it. This is why it's good to have the code, right? So let's drop my table. Let's go back and run my history again. I don't have Twitter username and username. I just have that, just Twitter. All right, then I can try then it goes, so it goes Twitter, then marital status. I'm ignoring these column headers because they're wrong. Then it goes income. Then it goes own a home, which didn't come in because that got put into the int column. Then it goes education and favorite department. Okay. And then we've got our row format delimited, fields terminated by, and table properties. Now, here's the fun part. Because I dropped the table, the data's gone because it's an internal table. When I drop that table, now that I made this new table, if I go select star from surveys, it's gone. There's nothing in there. And so now I have to reload the data. But again, as long as you have your history, it shouldn't be hard. And then now when I select Let's limit to, see if that's right. There we go. Now I've got the right thing. Okay, I got Twitter user ID, marital status, own a home, no, yes, education, favorite department. So I got everything I need. I think I have answered 4. Answered 4. Okay, now it's time to move on and do some Hive querying from Spark. That's what we're going to start doing with 5. So let's go into Jupyter Lab now. Let's go into Jupyter Lab. And it says make a new, I'm just going to make it right here, make a new file, new notebook. Okay, and let's save it as Lab C. And what else do we need to do here? Copy over the code from the example to create a Spark session connected to Hive. Okay, I can do that. I'm good at copying code. I got it right here. All right. I need this cell as well. So let's just put this in here first. And then in front of this, I need my imports. It's going to give me my Spark session and connect it to the Hive Metastore. And you won't see much happen here. Because honestly, there's not much going on until I actually try to do something and then get output. I won't see much of anything. I already have some tables in Hive, so I should be able to immediately query these tables. So I guess I could do this to make sure things are working. I could do like SQL equals, and then the triple quote is nice in Python because it lets you create multi-line code. So I can say select star from lab C is my database, right? Customers. And then I could say spark.sql. And then I don't like to, maybe I should call this query. This should work. Query. Now this is lazy evaluated. If I do that, nothing will come back. This is a data frame. So I have to show the data frame if I want to see output. And then it will run my Hive query. See that? Now I see output. Oh, it looks like I have a header in here. It did not skip my header like I thought it would. What about surveys? Did surveys come out right? I'd have to fix that. Nope. Surveys still has that header, that pesky header in there too. I thought I told it to skip that header. So let's take a look here. I can do a describe from here. I don't know how it's going to work. Describe. Describe extended surveys. Let's see what happens here. Okay, yeah, it doesn't, I can't do this because it doesn't return a data frame. So these kinds of commands I'm still going to have to do from over here. I thought I had the table property set. Why is it not working? It's working here, right? Lab C customers. Yeah, it's respecting the header row here. Interesting. So I wonder why this respects the header row, but Spark does not. That's a head scratcher. Let me dig a bit. All right, from everything I've read, it seems to be a known issue in the version of Hive with the version of Spark that we're using. So there's really not much we can do about it other than live with it. One way that you can sort of eliminate this is you can filter it out. I know it's not ideal and it's sort of a hack, but it works in this case. I can say where C email does not equal email, like that, because we know we don't want, that's not a valid email, right? And then that will take it out. It's not ideal, but that's the way the cookie crumbles in this particular case. Unfortunately, because like I said, the version of Hive we're using, which is the 2x version of Hive, and the version of Spark, which is the 3x version of Spark. This is just an issue that's out there still. I think if we upgraded the version of Hive, it would be okay, but the version of Hive we have is very compatible with Docker, so that's why we're using it. Anyway, so we hit the end of the internet, and that was kind of fun, but there's our workaround. But let's get back to and answer the question. So we are in 5. It says Notebook Lab C, and separate cell, write Spark SQL going to join customers to surveys on the email address. Include all rows and columns and show output in the notebook. Provide a screenshot of the notebook cell. Okay, so here we go. I am going to do my table join. So I'm going to go back to my, and then I'm going to say from Lab C customers, join. I'm going to actually make this look nice. Lab C customers C, and I'll say select C dot star, and then S dot star, join Lab C surveys. S on C dot email, C dot C email, S dot C S email. And I'm taking this where clause out until I know I need it. Let's see what this does first. I got a boo-boo somewhere. Cannot resolve S email. Okay, so let's take a look at these columns and see which one is the right one. C.S email. Okay, wait a minute here. Oh, I named them both C. What a knucklehead. There we go. All right, and there's my output. Now this output is tough to read, so I can zoom out until it becomes a little more tabular. There we go. I mean, it's not ideal. View left sidebar, turn that off, turn it up. There we go. Okay, and now you see all my data, and you see I still have that stinking header row, which I can get rid of by filtering out either C email or S email equaling the word email. See that? So I'm going to do that back in my code. I'm going to add my hack where I say where C.C email does not equal email. I know, it's a hack. But sometimes this is what you need to do in the world of Hadoop. You need to do a little bit of hacking. Okay, so now I have my table join. I can't wait to see what I'm going to make you do next. Let's go read the homework. The marketing department would like a data set of customer surveys for analysis. In a separate cell in the Lab C Jupyter Notebook, write a Spark SQL query to create a Hive table called marketing in Avro format from the select query that once again joins the customers and surveys on email address, including only the following columns in the new table. Now I'm going to remember all these columns, so I'm going to copy them. Copy these. Let's go over and take a look here. So here's my code from before. And let's make another cell. And I'm going to paste in this information. And I am going to grab the code from before, because it's good code. And let's drop that down here, like so. And I want household. Now, here's a fun thing. Like if I need to know which columns are which, I can do a print schema here because it's a Hive, it's a Spark data frame, and I can see all of the different tables. So this will help me figure this out. I need household, I need, they don't want name, they want to keep it anonymous or semi-anonymous. So I need C gender, and then I need C city, C state, and what else? Marital status, which is over here in the S territory. I'm not going to spell that right. It's too late in the day. Just copy it. And household income, which is right there. S income. This is just SQL. It's SQL that you probably already know. It's just you're executing it in Spark using the Hive data warehouse. Okay, I get my print schema now. Those are the columns, and then let's maybe show it, see what it looks like. That's the data I want. Now they want me to put this data where? They want me to put this data in an Avro file format. So I am going to need to use the pattern in Spark where I select the data into a table. I'm going to create a table from a select statement. It looks something like this. Whether or not I can do this in Spark remains to be seen, but we're going to try it, right? It looks something like this. You say, oh, I don't know. I'm just going to grab a cell here. You say something like this: create table whatever, stored as Avro, as select statement. And there's my select statement right there. So let's see if this works. Create table, and what did we want this thing called? Naming stuff's the hardest part. Marketing? Horrible name, but whatever. Marketing. Okay, stored as Avro. This is, by the way, incredibly common in the world of Hive. You have a bunch of data all over the place. A lot of it is external tables. And then you take that data lake and you package it up into this, which would be considered a data mart, which is a nice glossy table that's perfectly prepared for analytics. Like you can take this and just get it into Tableau and go nuts. And that's the idea behind the data lake mentality, is all your data's there, and then you use the transformations in Hadoop to package it up into some kind of analytic bundle that is easy to use. I don't even know if this is going to work. Let's see what we get here. Okay, I get no output, which is awesome, which means it made this marketing table. It means the command worked. And so let's try to do this. Let's go, first of all, let's go look and see what it did. Let's go to Hive Warehouse Lab CDB. And is there marketing? I don't. Oh, you know why? I didn't say Lab C marketing. Oof. All right, let me go fix that. It probably created it in the default Hive database, which is not what I wanted. Okay. And now I should see a marketing. There's marketing. And in there is, this is the MapReduce output, and this is an Avro file. Okay. And it's in the Avro file format. Let's go see if I can query it. So let's do a, query equals select everything from Lab C marketing. And then let's say Spark SQL, whoops, it's off screen, query. And let's show the output of that. Boom, there we go. And you can see that's considerably faster because that Avro file format is a non-textual format and the schema is with the data. So this is going to be, even though it's on Hadoop, it's going to be much faster than querying the raw data. And this is a game, like I said, that we like to play with Hadoop is you might have a batch job that loads the data into the external tables. And then after the data is loaded in the external tables, it recreates this marketing table as an Avro file from the query that's necessary to sort of combine a bunch of data together so that you can tell a good story with the data that you have. Okay. And then this table can be queried just like anything else. And if I had an ODBC driver for Hive, I can load this into Tableau. I can take it out of big data and load it into Tableau or load it into R or Python even, or even load it into Power BI or Excel so that I can do, you know, a pivot table or whatever the heck I'm going to do with the data at that point. All right, let's go on to number 7. It says stupid marketing doesn't know what they want. Well, this is pretty common. It's common for, I mean, I use the word stupid, but it's pretty common that people don't know what they want. It happens all the time. And now they would like the same query in the previous step, but they want the output as a CSV file instead of a Hive table. So yeah, this sort of happens a lot. Like, you know, they want the output in a different format. To this, I would normally say, guess what? You will get your Avro file and then use, you know, some kind of ODBC driver to query it and get it into Excel, then make it small data. But if you want to keep it big data, there is a way to do this in Hive, and this was kind of the point. There's that command that does it does insert overwrite directory. It looks like this. It was in the notes again, insert overwrite directory. Okay. And they want us to make a user root marketing. All right, so let's see if we can make some magic with this. It's going to look like this. I can actually use the Avro file I already made to do this, to actually make my query a lot simpler so that I don't have to use this behemoth up here. So check this out. It would look something like this. You say insert overwrite directory. And the directory is on HDFS, and it's going to be user root marketing. And that's a path. And then what I need to say is how is the files in the directory going to be structured? They're row format, delimited, fields terminated by a comma is what they wanted, right? And then I don't know if I need an as or not. As? We'll try with as. All right, I got an error. Yeah, it does. Look at that. It's like, no as, buddy. Yeah, so, okay. Let me get rid of the as. Oh, got another error. Directory doesn't exist. Yo, this is a nasty stack trace. Nobody likes nasty stack traces. My guess is it says error call while calling target. My guess is that the path doesn't exist. I'm really not seeing anything that tells me that. Let's just be safe and make this marketing folder. Okay. So I need to go back to my Hadoop client and do the Hadoop fs mkdir user root marketing. Could be the problem. marketing marketing. All right, now that the folder's made, let's see if it works now. It still doesn't work. Cannot create staging directory. User root marketing. 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 Let's see here. Did I do that right? Marketing. And then let's go check here again. User root. Oh, there it is, marketing. I don't know, maybe I'm spelling it wrong. Who knows? I'm just going to take this and copy it. You've seen it. I've looked at it so many times that it looks different. No, it's the same. Row format delimited, fields terminated by comma, select star from lab C marketing. Interesting. All right, my hunch is that because this query is not a data frame, that I cannot do this. See, there's some Spark SQL that you just can't do. There's some Hive that you just can't do within Spark. And I think this is just one of those Hive commands that cannot be done here. So I'm going to copy this, copy it, and just to show you I copied it, I'm going to paste it over here. There it is. And I'm going to go to my Hive Beeline client, which is down here, and I'm going to paste it in. And now it works. And just to show you that it's really there, let me go back to Hadoop here. And there's marketing. And then there's the output. This file here. And let's just to prove once again that it's there. If I go to the Hadoop client and say Hadoop fs cat to see what's inside of it, and I ask for user root marketing, and then everything that's in that folder. First of all, I'm in Hive. I'm not even in the right place. There we go. That's the right one. Hadoop fs cat user root marketing star, and see everything that's in there. And the output now is CSV. See that? Ta-da! So it did work. It's just I had to do it from the Beeline client. I could not do it. I had to do it from the Beeline client. I could not do it from within Spark. That's the way the cookie crumbles there. You're going to find that this happens a lot because unless what is returned back is some kind of data frame, Spark just won't be able to process it. Okay, so I think I did the entire homework. That was question number 7.